Conductors. The choice of the conductor material, size and design must take into consideration several factors such as ampacity. I'll write here. Ampacity. Ampacity means current carrying capacity. Current carrying capacity. It depends on the resistance of the conductor or conductivity of the conductor. So, higher the conductivity, the ampacity will also increase accordingly. Second is voltage stress at the conductor. Voltage stress at the conductor. Voltage stress, for example, if this is the conductor size, then on the surface of the conductor, roughly V by R will be the electric field, or it is inversely proportional to radius of the conductor, roughly. So this is going to be important factor. Higher the conductor, lower is the higher the conductor size, lower is the electric field on the surface of the conductor. So depending on the requirement of the electric field on the surface of the conductor, because on the surface of the conductor you will have insulation starting from there. So here, what will be the electric field requirement? Based on that, you have to decide the size of the conductor. So this is also an important factor. Then voltage regulation. Voltage regulation means voltage drop across the length of the cable. So this need to be considered. Under AC and DC it has different consideration. Under DC it is DC resistance only, which is normally considered negligible. But under AC, the inductive reactance of this comes into picture. So that needs to be considered. So then next item is conductor losses. So in order to reduce the losses, we do need the larger conductor cross section. Therefore, that also determines the size or design of the conductor. And then bending radius. Bending radius means the cable needs to be installed in several places where there may be a requirement of bending the cable. But it depends on the nature of the conductor. For example, if it is a single solid conductor, you cannot bend very sharp. There is a problem. So if it is made up of strands, several strands and all, so then it can be the bending radius can be decreased. So this is an important consideration. It decides the flexibility of the cables based on the requirement of the laying, etc. So the design depends on bending radius requirements also. Then overall economics. Overall economics means, for example, aluminum is cheaper than copper. So whether it is to, if all other factors are not so important, then we may choose aluminum to reduce the cost, etc. So this also influences the design of a conductor. And then material considerations that we see soon. Material considerations and then mechanical properties. Mechanical properties. So these determine the size, the material and the design of a power cable conductor. Now material considerations. Let us see what are the material considerations. So primarily we have two contenders based on the conductivity and cost, etc. We have two contenders. One is copper, another is aluminum. Which is better? So it actually has to be looked into very carefully, comparison of these two metals, because advantages of one may outweigh the disadvantages of the other. So we have to see very carefully. The first property which need to be seen is DC resistance, whether it is DC resistance. DC resistance of aluminum is about 62% of that of copper. Aluminum DC resistance is 62% of that of the copper. Therefore, an aluminum conductor must have a cross-sectional area of around 1.6 times that of the copper. For same DC resistance. Because its conductivity is just about 61% of 61 to 62% of the copper. Therefore, we need more cross section because the resistance rho L by A, right? So, since its conductivity is just around 62%, our resistivity is more. Therefore, we have to increase the area in order to reduce the overall resistance. So, this difference in area is actually approximately equals to 2 American wire gauge, 2 AWG. Next is weight. The aluminum weight is, the density is low, So, therefore, the aluminum weight is lesser than that of the copper. So, for same equivalent DC resistance, the weight of the aluminum is just around 48% of copper. So much, less in the weight, and it's very important for overhead lines actually. So, this is for same DC resistance, means after for same DC resistance you should have 1.6 times of that area. So, even after increasing the size by 1.6 times, then also the aluminum weight is just around 48% that of the copper. So, this is the very significant property of aluminum. So, wherever there is requirement of weight, for example, overhead lines. So, where if the weight is more, then the sag will be more and it has problems like that. So, there aluminum can be used. And then other places is underground cables also, where the space is not a matter. There also these aluminum can be used. Next is ampacity. Ampacity, of course, depends on the resistance value. So, the copper conductors do have better properties because of the less resistance or high conductivity. But obviously the aluminum cross-sectional area required is more compared to that of the copper due to its low conductivity. Then comes voltage regulation. Just now we have seen voltage regulation. Voltage regulation for wire gauges up to number 2/0 American wire gauge for AC case, and for DC case also. For a DC case also. So for smaller AC cables, small diameter AC cables as well as for DC cables, the effect of reactance is negligible. That is inductance or reactance, inductive reactance is negligible. So if reactance is negligible, then only resistance will be there. And equivalent drop results with an aluminum conductor that has about 1.6 times the cross-sectional area of copper. Both will have same regulation. So if an aluminum conductor is of 1.6 times in cross-sectional area as that of the copper, then both of them will have same voltage regulation for small AC cables and as well as DC cables. But large diameter AC cables, this won't apply because skin effect will be there, that we will discuss after some time. Proximity effect. When two conductors come close. So these two effects and then the inductive reactance role becomes predominant. So due to these, there will be voltage drop across the cable. So now as a comparison, if we compare aluminum and copper, now this 1.6 becomes 1.2 roughly, 1.4 roughly. So 1.4 times that of copper if we use, then the same voltage regulation means the drop along the length of the cable will be more or less same for 1.4 times that of the copper in case of large diameter AC cables, or it is 1.6 times of the cable if the size is around up to number 2 American wire gauge. Next consideration is short circuit. What is the importance in short circuit? Short circuits do occur faults do occur on transmission line. So whenever short circuit occurs, these faults occur, large current flows through the conductor. Now what will happen? Anyway, copper will have better these short circuit properties, but of course we need to consider in the short circuit condition what is the material that is surrounding the conductor. So this is insulation, and then above that sheets, jackets, etc. will be there. The central one is of course conductor, you can see. So surrounding the conductor there is insulation. What is its tolerable temperature, maximum tolerable temperature? And surrounding this again you have sheet, jacket, etc. On these, how much temperature they can tolerate. Based on that, the short circuit considerations have to be taken into account. The size of the conductor, etc. Has to be designed accordingly. Then other important factors, among other important factors, we have these other factors. Among other factors, aluminum has certain properties. It tends to creep and also oxidize rapidly. Creeping means, it is deformation, slow deformation. If it is under even less than the actual stress, under that condition also slowly aluminum gets deformed. And also whenever it is exposed to environment, for example, if you remove the peel of the cover of conductor, so immediately it oxidizes. Oxidizes means above this conductor there will be a layer of metal oxide. All metal oxides are insulators actually. So this is aluminum oxide, which is actually a dielectric material. And aluminum immediately oxidizes. So these do not occur in case of copper. So that is very, very important. That is why aluminum is not used in generating stations, substations, or portable cables, because for portable cables also this is not used, because the lower bending life. So you might have observed in old cables used in household this thing. If the conductor is aluminum, it becomes brittle after some time also, due to oxidation, excessive oxidation, and then bending of the cables, etc., will easily damage the aluminum cable. That's why under these conditions it is not used. Wherever even mechanical properties are important, there also these aluminum cables are not used. Space is frequently a consideration at such location also. However, aluminum is used overwhelmingly for aerial conductor, overhead conductors, as well as underground distribution, where conductivity to weight ratio is high for aluminum. So these are the considerations basically of choice of the material for cable conductor, with either overhead line or covered conductors or cables. So these are the main considerations for the choice of material.